Imagine a computer that can think like us. Well, almost. That's what neural networks are designed to do, mimic the way humans process information. We use them to tackle challenges that regular computer programs struggle with, like facial recognition, identifying objects, and classifying images. Humans don't need to think much to recognize whether someone is Lily or not. As humans, we can recognize things in an instant. This is a cube, or that's a dog. It's almost effortless for us. But for a computer, it's not that simple. Instead of seeing a face or an object, it sees thousands of tiny dots, pixels, forming an image. What we call a cat, it sees as a long list of numbers. And even if we take an identical picture in the same setting, the numbers will change. Adjust the brightness or take a new photo, and the entire set of numbers is different again. With so much variation, how can a computer ever figure out what it's looking at, let alone recognize a face? Here's the secret. We teach the neural network by showing it thousands, sometimes millions of images. It begins to learn patterns, recognizing what a cat looks like across all those examples. But we don't just show it random pictures. Each image comes with a label, a kind of cheat sheet, that tells the network what it's seeing. This approach is called supervised learning. As the images pass through the neural network, they move through hidden layers. Each layer has its own job. One detects edges, another might focus on colors, and another counts the legs or even notices horns. Eventually, the network makes a prediction. It guesses what the image is based on all the information from those layers. But the real magic happens between the nodes. Sometimes the network gets it wrong. No worries. We adjust the weights. These are like invisible connections between nodes that determine how much influence each piece of information has. By tweaking these weights, we teach the network to get better. Over time, it becomes an expert at recognizing our images. This fine-tuning process is called optimization. Once optimized, we can save the neural network and use it again and again. Now, if we show it a picture of a goat, it knows exactly what it's looking at. But show it a dolphin and it's clueless. That's what we call narrow AI. It's smart, but only within a limited range. And it's not just images. Neural networks can analyze text, sound, video. Basically, anything that can be turned into numbers can be understood through this powerful process.